Hi folks, welcome to World of Vision 360. It's been long since we met, right? Now we will upload videos on every Sunday. So without further ado, let's get started. In this video, we are going to generate the design for this bracket. It's an automotive seat bracket where a seat will be having a hollow shaft and it will be inserted in this cylinder, and a bolt is mounted on its top to the floor of the automobile. So here we have two preserves. One is cylinder and one is the bolt geometry. So let's create the geometry for those two. I'm gonna create sketch on XZ plane. So see on the keyboard, original center, draw a circle of 28 mm dia. I'm gonna finish the sketch and select extrude. In type, we have two extrudes, general extrude and thin extrude. So we are going to select a thin extrude for this scenario. We need a cylinder that is hollow. So generally what we'll be doing is we will create a offset circle, and then we will select the inside profile and then extrude. So you can select the external geometry and then give extrude having thickness. So I'm gonna select thin extrude. I'm just gonna drag the arrow to see the preview, and in the direction to be symmetric, whole length, and the distance be 65 mm, and the wall thickness be 2.3 mm. I'm gonna say OK. I'm gonna save my design so that I won't lose when it hangs. Now that a body is created, I'm gonna create one more body for bolt mount. So for that, I'm gonna show the origin. So I want offset plane of XY 25 mm downside. I'm gonna select offset plane. Then I'm gonna select XY plane, and the distance be negative 25 mm. If you want to extend the plane, you can just select on the any edge and just drag. I'm gonna select this plane, create a sketch. See on the keyboard or select circle from here. I'm gonna draw a circle of 8.2 mm and make it horizontal with the origin, and the distance between 2 points be 25 mm. And I'm gonna do the same like we did for this cylinder. Select extrude, switch to thin extrude, and now the profile automatically selected. Just drag it to see the preview. So I want the material to be outside. So in the wall location, you can switch to side 2. So in this way, the profile extrude is created on outside, and the distance be 4.5 mm and wall thickness be 5 mm. I'm gonna say OK. Now that we have created two bodies, so these are going to be my preserves. So I'm gonna hide my origin and rename the bodies, and body 1 as cylinder and body 2 as bolt geometry. I'm gonna switch to generative design from here. So it asks you to select this type of study that you want to do, structural component or fluid path. For now we are going with structural component. I'm gonna create a study. We have defined the main geometry that we need. So we need to tell the software that you should not fill at these areas. So we are going to create that geometry now. I'm gonna select edit model. So if you're not having any preserves that were already designed in the main workspace, you can create one more preserve, or you can create obstacles, or even you can delete some features that are not needed for this setup using edit model. I'm gonna enter to edit model, and here we are having all the basic features that you're having in a design workspace. So an additional feature that you get in here is obstacles. So these are like bolt areas. So we need to define those areas so that the generative design understands that you should not fill the material at this area. So I'm gonna select connector obstacle, and it asks you to start of the shaft. I'm gonna select this edge, and the end of the shaft be this edge. So Fusion automatically detects what is through that geometry. So this is the geometry that we cannot see now, right? But if you hover over to that, it will just highlight that edge where you can select. If you don't get this option, under select and selection filters, here we have select through. If you enable this option, you can select the hidden edge. So I'm gonna select that one, and so it just filled the material from start of the shaft to end of the shaft. Now we need bolt head for that connector obstacles, because we want the geometry to be here also, like it should not fill the material extending this face. So we are defining that. I'm just gonna adjust the length to 15 mm, and I want the bolt head to be on both sides. So if you flip it, it will just reverse the direction, and if you select both sides, it will pop on both sides. If you want tool clearance, additional tool clearance, you can check tool clearance, and it will provide additional geometry so that you have more space for putting the tool. I'm gonna deselect tool clearance and say OK. Now that we have created connector obstacle for cylinder, now we need to create for a bolt geometry. I'm gonna repeat connector obstacle. I'm gonna select this edge, and I'm gonna enable bolt head. As soon as you select that, it will enable the shaft and bolt head. I'm gonna select end of the shaft. So in this for this geometry, it is not highlighting the inner inside hidden edge. So you can just hold shift and or press the middle mouse button to orient it and select the hidden edge, or you can use the view cube to orbit. You can select this ISO view, and you can easily select or pick the edge. I hope you got this point. Now that I have selected both the edges, I'm gonna click on bolt head, and I'm gonna increase the bolt head diameter as 15 mm, because the bolt head will be little larger, and we need to insert the spawner so that we can access the bolt, right? So for that, I just increased the diameter to 15 mm, and we need a tool clearance also if you are using some larger T-bit tools. So I'm gonna enable tool clearance in this scenario, and make sure that you extend a little so that the generative design knows that we should not fill material, just for a safety purpose. I'm gonna say OK now. Now that we have created two obstacles, so now we are done with the edit model. I'm gonna finish edit model. When you get back to generative design workspace from edit model, it automatically selected those connector obstacles to obstacle geometry. So in the design space, we have preserves and obstacles, but if you do not want that as a criteria, you can select this, and you can deselect any of the two geometries that were created. For now, we need those two as a obstacle geometry. I'm gonna say OK for obstacle geometry. I'm gonna select the preserve geometry. Select these two bodies and say OK. Now almost our geometry is defined. I'm gonna hide obstacle geometry. I no longer need those to be viewed in my workspace. So I'll just click on this eye icon to hide it. Now I'm gonna select structural constraints, or you can press C on the keyboard to pop up this menu. Now in ideal case scenario, what happens is this bracket is mounted on the floor of a automobile, and the cylindrical shaft comes from the seat, and it goes from this end to this end. So when passengers sit, the load is going to act on the floor, but it won't act on the cylinder. When we brake the vehicle, the load of the passengers will act in front direction. Similarly, when the vehicle starts suddenly, the load is going to act backward direction. So we are going to define those two load cases in this example. For the bolt geometry, I'm going to select the inner face, and as soon as you select that inner face, you can see this lock icon. So it means that it is fully locked, so it cannot move in any direction. So here we have axis to be selected. So in this phase, if you switch to top view, it cannot move in X direction and Y direction, but it can traverse in Z direction. So there is no this phase cannot be held by the bolt in Z direction. It can only lock in the X and Y direction. Okay, so the axis that I'm referring is from the view cube. So it cannot move in X direction and Y direction. I'm gonna deselect Z now because it can move in Z direction. Say OK. And now repeat structural constraints by right clicking and hovering your mouse to the 90 degrees, or you can simply select a C or from design conditions. Select these two phases, top and bottom. So if you're not sure that you're selecting the top or bottom, you can press left mouse button, and if you hover over to the options, it will just highlight the phase that you're selecting. So I'm gonna select this phase, that is bottom, and this phase can only lock Z direction. It cannot lock X and Y. So I'm gonna deselect those. So as soon as you deselect them, the lock button here is getting unlocked. So it means that it is not fully constrained in all the directions. I'm gonna say okay. Now that we have defined the constraints, let's define our loads. So if you click on structural loads, so in the type we are having force, pressure, moment, bearing load. So as I have told you, the passengers, let's say the 5 passengers are sitting on the seat, and vehicle suddenly applied brake. So the load is going to act in a front direction, right? So because the passengers are moving, the vehicle is trying to stop, but the velocity of the passengers do not rest suddenly. So the load acts front direction. So in this scenario, I'm gonna select this phase, and the force to be, if you select this force as a type, it will act like entire cylinder. I'm gonna orbit so that we can clearly see what is inside. So it has selected all this phase, and now I'm just gonna orient it in minus 90 degrees. Just make sure that the arrow is pointing in this direction, and so this entire weight acts in all the cylindrical face. Now I don't want this to happen. So when in ideal case, what happens is at from half of the section, the maximum load acts at this center, and as you go from this center to the top, the load decreases and the load becomes 0 on the top. Similarly on the bottom at this area. So for that type, we are going to switch to bearing load. So as you can see this icon, the maximum force is going to act at the middle and the minimum force at the edges. So I'm gonna orient the view minus 90 degrees and the load be 2500 newtons. I'm assuming 5 passengers sitting on the seat. So having 100 kg each, the total load would be like 500 kgs, and 2 clamps will be there sharing half of the load equally, so 250 kgs. That's 2500 newtons, taking G as 10. I'm gonna say okay now. Just rename the load case here. I'm gonna select, and if you click again, it will just enter to rename mode. I'm gonna rename it as front load. Just clone the load case and rename it as back load. Now click on this radio button to activate it and just reverse the direction. Make sure that the arrows are pointing in reverse direction. We are defining condition where the vehicle suddenly started. So in this case, the entire load is going to act in reverse direction. I just reorient it in opposite direction. Now that we are done with our load cases, let's move to design criteria. This is where we set the factor of safety and the target mass and stiffness. If you select on objectives, so it will pop up objectives, limits, and other various factors. Here we have minimize mass, maximize stiffness. So if you select maximize stiffness, it asks you to select the factor of safety and target mass. So if you want to reduce the mass by certain limit so that you want exactly this kind of mass, so you can select a maximize stiffness option. So having that mass, it will maximize the stiffness. So for now I'm gonna select minimize mass. And also here we have model frequency. You can set the frequency and the displacement and buckling factor of safety you want. I'm gonna say okay now. And then we have manufacturing. I'm gonna select manufacturing. Then I'm gonna check cost estimation. Select the production volume. That what unrestricted does is, without considering all the manufacturing criteria, it will just generate the design. So here I'm gonna check additive. So it asks you to select the orientation. I'm gonna include all the orientations which my nozzle direction is. So it will consider all the directions and it will generate the design. So you can define overhang angle and minimum thickness that you want it to be in the design. In milling, here we have 3 axes already configured, and the tool direction I want it to be like we can machine this hole in Y axis and this hole using Z axis, but not in X axis, right? So I'm gonna select all Y and Z axis. And minimum tool diameter is, we know that the tool, this whole dia is 8.2 mm. I'm gonna set the minimum tool diameter as 6 here, and shoulder length as 15, and head diameter as 20. So 2-axis cutting won't support in this scenario because these two holes are not parallel to each other. So these axes are perpendicular to each other, so it won't apply in this example. So die casting, I'm gonna check die casting, and the ejection direction to be, so here also, so the holes are perpendicular to each other. We need to consider in ideal case scenario the two holes to be parallel, but with some inserts it is possible, right? I'm gonna say the ejection direction as Z and Y. And one more thing is, I'm gonna define 5 axis here. If you hover over to the configuration 2 and if you expand, here we have 2.5 axis, 3 axis is already defined, and 2.5 axis is also not suitable because the tool comes in from top direction and it cannot access the other hole. I'm gonna select 5 axis and change the minimum tool diameter to 6 and shoulder length to 15 and head diameter to 20. So now we are done with the manufacturing setup. I'm gonna say okay. In the materials, I'm gonna add materials to all the methods at one time. So currently I'm in additive material library, metal. I'm gonna pick all the materials, whichever is applicable. I'm gonna just drag and drop the materials. After you're done, just close. So here we are having a pre-check. If you click on this, it is saying that the red means some input is missing. So you just need to give your inputs perfectly so that it will turn to yellow or green. So now it is showing red, saying that cannot generate. Some preserved geometries are interfering with obstacle geometries. Click this message for more information. So it is saying that the preserved geometries are interfering with the obstacle geometry. We will inspect that in edit model. I'm gonna select interference under inspect. Then I'm gonna select these two bodies, say compute. So there is an interference found here. So this obstacle is merging with the preserve body. So we will just edit this connector obstacle. Double click on this second obstacle and just reduce the diameter. I'm gonna say 20 mm. I'm gonna say okay now. Finish the model. So it is saying that stainless steel ASI 304 is not supported for cost estimation, die casting. And similarly titanium for die casting and Inconel for die casting. Stainless steel 174 pH for milling and die casting. We are going to remove those and add other materials for that particular manufacturing method. I'm going to close it, and if you click on materials, if you go to die casting, you can see a calculator button next to the material. For this material it is not having. Similarly for the other materials, I'm just gonna right click and delete those. For those not having the calculator button, which is cost estimation. So for die casting, I'm gonna add more metals from Fusion 360 material library. In the metal, I'm gonna add aluminum. Make sure that you add the materials having cost estimation. For milling, similarly I'm gonna delete these materials. You can add more materials. I'm gonna add steel for now. That's all. Now it turned to green, saying that everything is ready and it has all the information that is required. Now if you click on previewer, it will just generate the material roughly from a maximum point. Here you can see the material is getting generated considering maximum criteria. It will optimize and converge with your results when you submit the generative study. I'm gonna stop the previewer and click on generate. Here we are having one study. If you're having multiple studies, it will show subsequently and you can check which study that you want to be generated. I'm gonna click generate one study. What it does is it will send all the data that we have defined to the cloud and it will solve there, and it will show us the results when it is done, or you can view the results in live. For this study you can even close the Fusion 360 or even your PC. It won't affect your study at all. If you expand, here you can see the rendering is 100% completed. When you see this one, you can just close this dialog box or even Fusion 360. If you make it stay open, it will switch to explore view and then it will show you the results in live. You can watch the results live generating. it is saying that the outcomes will appear as they process. Currently we are in Explore view. I'm gonna finish Explore. Generative design study is completed. You will observe check mark here. Then you can go to Explore to view all your results. We will explore that in part 2. So this is all for today. I recommend you to watch my previous video on generative design for more insights.
Thank you so much for watching this video. Hit that like button if it helps you, and subscribe to World of Vision 360 for getting notifications each time when we upload new video like this. Thank you so much guys. Have a good day. Bye bye.